All right, in this video I'm going to be talking about quality in the context of experimental work. Let's begin with the question, what exactly do we mean by quality? When I think quality, I think about a Ferrari. So what does quality mean? Well, people love this. It drives well. People will pay money for this. So I define quality in experimental work. It's a degree of excellence created by the team. This means that people will pay you money for doing this experiment. This means that your experimental work delights the human spirit. So if we want quality in experimental work, what exactly do we do? How do professionals produce quality in experimental work? This slide shows 5 dimensions of quality. And there's probably some other things, but these are 5 really good ideas. These are the how-tos on producing quality in experimental work. Number 1, you figure out a motivating rationale. Number 2, you get really valid methods for doing your experiment. Number 3, you do a killer literature review. You really find out what people have already learned. Number 4 is you create very useful results. And number 5, and the most important, throughout your experiment, you apply the ideas and the values of the scientific method. Next, let's look at each of these dimensions of quality. Okay, let's imagine that you've completed your experiment and you've documented your results. This could be a report, it could be a journal article, it could be a website, but there's documentation of your experiment. And then we have a very experienced person reading your documentation. And there's 2 characteristics about this person. Number 1 is they're super motivated. That is, they love professional practice. Number 2 is they're very competent in the field. They understand experiments, they understand the technical knowledge. And so this wise owl, if you will, is going to be looking at your written document. And the idea is that this person will not have the ability to talk to you. They'll only be able to measure the quality of your experimental work by looking at this document. So I'm going to be talking about what this document looks like. To gauge the motivating rationale, the wise owl reads through your document and asks questions. When you explained why you were doing your experiment, did you explain how this will benefit people? Did you explain how this will solve a significant problem? Did you explain why your experiment is worthwhile? Because after all, we all hate busy work. And overall, would the reader of your report feel very excited? This is great work. The second dimension that your reader would be looking for is meaningful results. And meaningful means useful results. Here's some questions your reader will ask. As I read the report, can I easily find the results? They should be in the abstract. They should be at the end of the report. Are the results super clear? Are the results very useful to me and to other people, to the team, to anyone reading this report that's in the discipline? Do the results generalize to multiple contexts? Or do they just apply to one very limited and specific situation? The reader is going to be looking for a killer literature review. Here's some questions a reader will ask. Did the team find, figure out, and apply the very best knowledge available to help them do the experiment? As I read the report, is the literature review results, are these results super clear and super useful? Are citations used appropriately? Are the things that need to be cited? And did the team cite things that are common knowledge and don't need to be cited? Did the team in their report explain what is new about this work, why it was worth doing? Did the team explain how this work fits with what is already known? The reader will be looking for valid methods. Did the team align their methods with best practices in the discipline? Is this the way really good people do this? Did the team validate their results or their multiple checks to see if the results might be correct or the degree of correctness of the results? Did the team triangulate? And to triangulate means to measure things 3 or more different ways. And if these measurements all tell you the same thing, that provides strong evidence that the results are believable. Did the team calibrate their instruments? Did they make sure that everything was measuring correctly? Are the methods reproducible? And what reproducible means is that a competent professional could completely reproduce your results given only your report. In other words, you've told your reader exactly how you got your results. Now, a math model is not always part of experimental work, but in engineering, it's very, very common. Did you include a math model? Was one relevant? Did you document your math model appropriately? The reader will be looking at, did you apply the scientific method? And remember, this is really a belief system. So does it feel like the team is skeptical of their own results? In their documentation, did the team reveal potential problems that might make the results or call the results into question? Did the team discuss limitations of the results? Was an overall attitude that we're not trying to prove that we're good or trying to find a certain answer. We want to simply find out what is true. What does the data show us? Was the team careful not to overstate the results? And lastly, is the overall tone of the writing and the report humble? Here's the problem we took on. Here's how we did it. Here's some things that you should be aware of. And here's our results, just simple and clear. I've described 5 important dimensions of quality. In your report, tell your reader exactly why you did the experiment. And this should be very motivating. Make sure you present clear results, and they're very easy to find, and they're very useful. Follow the scientific method in your experiment and in writing up of your report. In doing your project, take advantage of the collective wisdom of humankind. Make sure you dig deep into all the available literature and then apply these ideas to really make your experiment better. And lastly, make sure you use valid methods. Make sure the methods of your experiment align with the practices of the discipline. Thank you for listening. I hope you have enjoyed this video.